I'm Katie McHugh, and I'm here at the World ADC Summit with Ravi Kiron, the CEO of Navia. And so we're here to talk about potential technology applications for antibody drug conjugates. Should we start, Ravi, by you introducing yourself and telling me a little bit about your background and also about Navia, which is a very new company, I understand.
Wonderful. Thank you very much for the opportunity, and I'm pleased to be here, and thanks for inviting me. So essentially, my background, I've been in the industry many years. I was at Cornell and then spent many years at Pfizer and then Johnson & Johnson. And now I'm more of an entrepreneur looking at novel opportunities. So Navia is all about a unique technology that can treat breast cancer tumors and photothermally ablate them and not have any side effect as a result. And this molecule is now only being tested in mouse, but will be tested in humans once we're able to raise some money. But at the same time, where it applies to ADC is how you can take a molecule like that, connect it to an antibody drug conjugate or an antibody conjugate targeted to tumors inside the body, and then activate that molecule from outside the body such that the cancer is killed.
So does the molecule have a name? Have you named it?
No, we don't have a name for it yet.
Okay.
So it's a fullerene molecule, it's a buckyball.
Okay.
It's a modified buckyball, and the advantage of this molecule versus anything else that's on the market is the fact that this is safe, non-toxic, biocompatible, and biodegradable.
So obviously in my next question you keep saying that it's safe, but it's been tested in mice models.
Correct.
So obviously we should probably talk about what signals now are telling you that it is safe, and then maybe we should talk about how its translation into the clinic and how you're very confident of its safety profile.
Okay. So the molecule itself is not really a novel molecule in the sense buckyballs have been known to exist in nature.
Mm-hmm.
It's got a number of beneficial properties. People actually even take a very dilute concentration of these molecules as an antioxidant. They drink it, and it's completely safe in that sense. So that's why I say that it is so safe that you can even drink it and not have any deleterious effects. But the modification that we've made to the molecule and the concentration at which it is there in the breast cancer tumor, now we can activate it such that the tumor is burnt up or combusted from within and kills the tumor.
So let me get this straight. So obviously it's safe in low concentrations, but we're obviously increasing the concentration here, but you're saying that it's benign until it reaches the tumor, or not, but its safety profile is benign until it reaches the tumor?
Yes, it's totally safe, but it needs to be activated.
Okay.
So it's got a photothermal characteristic. So what that means is you take light energy, and light energy shining on that molecule converts the light energy to heat energy. And so that heat energy inside the tumor kills the tumor.
Okay.
So it's a very simple concept, but of course we'll need to prove that low concentrations of it in the body is completely safe, and high concentrations when activated by the laser is where it is capable of killing the tumor.
And so can I also ask, how far away are you from the clinic? Are you...
That's a big question. So I need to raise money, seed money, angel money, VC money, whatever, if you've got some money. But essentially where we are right now is we've done mouse model testing, and it needs to be taken to the clinic, have an IND, and showcase efficacy in a human model. And once we're able to do that, then the value proposition of the technology goes up tremendously.
So are you testing it in any other animal models before filing the IND? How far away is that from?
Probably 2 years.
2 years.
And so after that, if it goes to an IND, the way I'm projecting it is probably in the next 8 years or so, it should reach the market. 5 to 8 years.
providing its
Providing
beautifully
everything. That's right. Absolutely.
throughout clinical development.
Absolutely.
Okay, so are you going to go into more of a complex animal models before
Yes,
that?
absolutely.
So dog
Sure.
or
Yeah, dog, and then ultimately probably in a non-human primate model too.
okay. And then, so my next question would be, obviously I'm very curious, as you're a new startup company, you're talking about raising funds. Can we talk about the economical market now and the prospects for doing that and yeah, if you could just fill me in on the business
Sure.
side.
On the business side, of course, it's a very challenging environment. Many companies are facing layoffs, they are downsizing R&D. VCs are not really investing in early stage startups because they don't know when their exit will happen. They don't know whether it'll be 5 years or 10 years and whether they'll even get their money back or not. And so in this environment, it's very challenging, but at the same time, I've always believed that if you have the right idea, and if you know the right person to go and talk to with the right pitch, you can get the money. There's a lot of money available in the US, in Europe, in Asia. Lots of people have made lots of money in various other fields, and they're all interested to invest in something which has a promise of success. So I think if you can target it effectively, like the ADC, if you can target it to the tumor. So here, if I can target my pitch to the right investor, I can raise the money.
Should we talk about anything else? Anything else you'd like to?
I just want to say that you guys have put together an excellent conference here. I think there's a lot of energy and enthusiasm among the participants, and hopefully bringing this kind of a meeting together of industry, academics, as well as biotech and the service providers will help raise the awareness of this ADC and hopefully identify new drugs for the future.